So the very last bit is the volume. And in order to find the volume of a shape that's being rotated, we're going to use two different formulas, and the formulas vary depending on where are we rotating them about. So this one is clearly rotating about the x-axis. This one is about we're rotating about the y-axis there, yeah? Now, in order to find the volume, to put it into this formula, you still will sometimes have to find the area, and that's the thing that we rotate. Some of them you might have to use integration by parts and substitution, but not a whole lot. So we can sort of go back and do that separately if you got stuck on those. Now, these are formulas that you need to make sure are on your help sheet. They are on your bookmark. The main thing that you want to add to these or to highlight is that when you are rotating around the x-axis, these A and B values are clearly, right, your x values. But when you are rotating around the y-axis, then these little doodads are clearly your y values here. Okay? And you will see in a moment that starts off really easy. The only fancy bit that you have to be aware of is that sometimes when you're rotating around the y-axis, they'll give you the x values. And you have to do just a little bit of substitution to find the y values. Now, not difficult, but it's a bit like the substitution bit where you're doing definite integrals and you need to remember to substitute back in. So I don't think this is anything too strenuous, and it's a good little thing just to refresh if you've been focusing on your methods investigations. When are they due? I could kill methods, honestly. That's just gone on for longer than forever. Anyway, we'll squeeze our little investigation in there shortly. So, if you haven't done so already, have your bookmarks out and find these where they are on your bookmark. If you've got your notes page, then make sure that you're adding these formulas there. We are on page 217. It's all beautiful. With all of these, it's obviously handy if you know what the functions look like. Did anybody get up to this, by the way? You're done. Oh, well, you can do your reviews. Read DayMap. There's a great question in the 2021. F2. Oh, so do other stuff until we catch up on F2. But have a look at 2021 exam. Have you all got your... I don't think we have to do every single one. It's if you want to go and practice. Do you want to pick one? Pick one, anyone? Who am I doing this with? Good. We've got a few people out in the crowd. So what shall we do? Shall we do the right-hand side? Do number 1. It's a bit boring. I'm looking at F and H. No, we'll do... Okay. Right-hand side. Around the x-axis or the y-axis. They're starting off very nicely and we're going, yep, beautiful, x. We have our formula, which is going to be pi times y squared, right, by dx. So very simple, we just slap it straight in. So if we're doing b, okay, we are saying our volume is going to be pi times this function squared. Don't forget to square it. That's a key thing that people forget. Right, so that'll just be x by dx. And what are we going to integrate it between? 0 and 4, right? Really simple. Like if this was a question, you'd be laughing all the way to the bank. So we end up pi x squared over 2. All nice. 4 squared is 16 divided by 2 is 8. So we get 8 pi units cubed. Why isn't there anything else? Because obviously when I slap 0 in, it is 0. Simple, simple, simple. Happy days? Don't forget that when you're doing h, you don't forget that you have to square it. What do you mean both of them? You square that, right? So that will end up being x squared plus, good, 2 plus 1 over x squared. And I write that as x to the minus 2 to help me. So just be aware of that don't forget to square. So see how you go. Shouldn't take long. Once again, you're reading, you're making sure, because we're about to do one where it's going to go around the y-axis in a minute. So we read, yes, it's the x-axis, so we're quite happy. Its volume is pi. We're doing a little AB doohickey thing, y squared by dx. So have we got y squared there? Absolutely. We just rearranged this, so this will be y squared equals 64 minus x squared, and that's exactly what we're going to pump in. Do you have to square it? Follow the formula. It's saying y squared. Have we got y squared? So that is your y squared. So that will just be 64 take x squared. And what are we going to integrate between? 5 and 8, and away you go. So the formula is there. Just make sure that you follow it. Okay? And look, I've done this time and time again, but how many, if I had $1 for every time that I have forgotten to square it? And you go back and you check and okay? And the other one you'll see in a minute when you do the y, when you rotate it around the y. That's the thing. So it's really important now that you're reading the question carefully. That's important. So B will be your answer to A. Just put it in milliliters or liters or whatever. So 6 is nice, as I said. It's got no numbers, it's letters. So go the process. You'll see, you prove certain things and find a formula. It'll be interesting what your formula is. Same with 7. But when we get into question 8, again, no big surprises, except we are now rotating about the y-axis. And so the only thing that you have to, well, we'll do 2. I think we'll do 2 of these. About what you need to be aware of, okay? So first things foremost, you're looking at its dy around the y-axis. So the formula that you are now going to put down, bless you, is its x squared, is what we're going to enter in there.
Yes.
Time of day, right? Okay, so don't just go, oh, x squared squared. No, we're actually putting in, that is our x squared, so you're going to now be integrating y with respect to y, and between 0 and 4. So that's pretty straightforward. Agreed? You keep on going, you go, okay, what about b? Same deal. We're going to say integrate x squared by dy, but we haven't got x squared. So how do I at least get x from this? I've got y equals root x. How do I get x? Square both sides. So now it's y squared equals x, which means you are now integrating, all right, don't get excited, you are now integrating this squared, so it's actually y to the 4. So nothing major, just be careful. And then, of course, when we get to d, and that will be between 1 and 4, what's the issue with d, anybody? All right, again, don't just predict what's going to happen here. So when you're doing d, we've got volume is, yes, pi, and I'll write it all. Okay, so it's pi. Now x squared, hell's bells, you're going to have to rearrange again. So this is going to be squared, get rid of the take 2, plus 2 gives you x. So that means we are going y squared plus 2 all squared. And so straight away you're saying, hey, I'm going to need to do what before I integrate? Expand. Ours on the money. And then the other thing is that with this 2 and 11, we will pop this in here. So when x is 2, y will be 2 take 2 is 0, square root of 0 is 0. How pleasant is that? So that will then be 0. And when x is 11, wouldn't you know it, 11 take 2 is 9. And the square root of 9 is a nice old 3. Funny how that works so nicely. So again, repeat, but you've got to make sure you read the question carefully. Yeah? So could I ask you to work your way through, do that. Thursday, planning on doing the 7F2, a little bit more intense with some of those questions, but still okay. And then you've got your double on Thursday, revise, all next week until Wednesday. Got the weekend to revise. Yes, James looks defeated. Sorry, mate. You're all right. Just a bit tired, but I think we're on track. If you check DayMap, I've said the integration question from the exam of 2021 in the first booklet. Awesome question. It uses synthetic division. It uses function notation. It makes you sketch the graph, and don't want to burst your bubble or whatever, but it also, within the integration, you're having to deal with fractions as well as substitution or by parts. I won't give it away. And the arc-tan and arc-cos stuff. So it's awesome. Great question. And before you ask, would that be a test question?